You've written a Java class and a program that creates an object of your class to test it, and it works perfectly. Then you add several more objects with different values to your testing program, and when you print the values, they're all the same. What's going on? This is Maggie from Design Code Debug Repeat. Welcome to the channel. We're going to dig into what's causing this problem, how to solve it, and why this feature of Java even exists. Let's get started. In my example, I have a die class, a class representing a die that you might roll in a game, and a program that creates 4 die objects, prints their face values, rolls them, and prints their new face values. When I run it, you can see that it prints the same 4 values, and then after sending the roll message to each die, prints the new values, which are again all the same. This happens over and over every time we run the program. Probability tells us that 4 fair 6-sided dice should all show the same value only about once every 216 rolls. So something is wrong. Here's the class diagram for the die class. It has 2 fields, num sides for the number of sides of the die, and face for the value of the die that is currently showing. It has 2 constructors, a noarg constructor that creates a 6-sided die, and a constructor that takes the number of sides as a parameter and will create an any-sided die depending on the value in the parameter. In the testing program, I'm calling the noarg constructor each time. It has a roll method, which should randomly generate the new face value, and it has a getFaceValue method, which should return its face value. In our testing program, we're printing the face value each die gets when it's created, then sending the roll message to each, then sending the getFaceValue message again and printing the result. Do you have any theories about what's going wrong? What would you investigate? Pause the video a moment and think about where this could go wrong and how you would zero in on the error. Okay, so hopefully you have some theories now. There are a lot of places this could go wrong: in the initial creation of the objects, in the display of the objects, or in one of the object methods, for example. If you copy-pasted your testing code when you created it, as I did when I wrote this, you might have forgotten to change your variable names. Maybe in the class methods you assigned values to the wrong fields, or assigned to local variables rather than assigning to fields, or maybe you're returning the wrong value from the accessor method getFaceValue. So my first strategy would be to look over the code for these kinds of errors. If you read over your code and don't immediately see the problem, an excellent strategy, the one I would recommend every time, is to run the program in the debugger. Let's do that. When we run in the debugger, we're looking for something in the program state or flow of control that violates our expectations. So it's important to clearly express our expectations. I expect that 4 separate die objects are created, that there are 4 die objects in memory after the block of code from lines 8 to 11 executes, and that each die has a num sides value of 6 and a random value in the face field. Some of them might be the same, but I do not expect all 4 to be the same. And as each roll message is sent, I expect the object receiving the message to get, again, most likely, a new value in its face field. And then I expect those new values to be printed when we get the values and print them again in lines 28 to 31. At least one of these expectations is being violated in this code. Let's get into the debugger and see where reality deviates from our expectations. I'll put a breakpoint at the first line that creates a die object and debug. I'm going to start by stepping over each of these lines of code to confirm that I have 4 die objects with different values, and if I don't, then I know the error is in the construction of the objects. So I'm going to do that. I'll step over the first, and I can see die 1 over in the variables area, but when I open it up, there's nothing there. Normally, I would see the 2 fields and their values, so that's odd. And I know for many of us, our inclination is to say, something's wrong with Eclipse. It can't be my code. Let's say I believe that. I'll get at the values another way. I'll click on the Expressions tab and type die1.face, and it has a value. It's 2. Okay, progress. Let me type die2.face, and there's nothing there yet, so let me step over the line of code that creates die2. Did you see that? Die2's face is 6. But now so is die 1's. Let me add die3.face just to see it happen again. And I step over the line of code that creates die 3, and now all 3 of them are 3. So the problem is happening right from the start when the objects are created. But what is it? Let me show you the code for the die class and see if you spot it. Do you see it? This is such an easy mistake to make for a person transitioning from learning methods in Java to learning classes. The error is that I've put the static keyword in front of the fields. Eclipse gives me a little additional information too. It italicizes static members. A static member is a word for field or method or class part, is a member that belongs to the class, not an individual instance or object. So we distinguish static members, which are part of the class, from instance members, which are part of an individual object. When we create the main method in our diceprogram.java class, which is where execution begins in Java, we create it as a static method, so we don't have to create an instance of diceprogram.java before calling main. And if we write a whole program in diceprogram.java without creating an instance of it, we will need to make all of the methods we write static so they can be invoked from main. Once we begin defining classes that are meant to be instantiated, that we're meant to make instances of, then we want to drop that static keyword most of the time. If we put static in front of a field, it belongs to the class and not an individual object. If it belongs to the class, there's only one copy of it, and it's shared among all objects. With static fields, each time I assign a new value to the field face, it replaces the old value, regardless of which object is responding to the message. So when I invoke the constructor for die1, and we go into the roll method and set this.face to a random number, it's setting the value for die.face, the face variable that is part of the class. When we debugged, that value was 2. And then when we invoke the constructor for die2, and we go into the roll method and set this.face to a random number, it's again setting the value for die.face. Now there are two objects, die1 and die2, essentially sharing that field. And it happens again for die3 and die4. The programmer who wrote this program did not mean for the fields to be static, and that is why they wrote this.face and this.numSides. But Java sees that the fields are declared as static, and it writes to die.face and die.numSides, the shared fields that belong to the class. In fact, if we look carefully at the code, we'll see a little warning next to the lines of code that prepend the static fields with this. If we mouse over, the warning reads, the static field die.face should be referenced in a static way. So Java is telling us this field is die.face, and this other field is die.numSides. To solve it, again, we remove the static keyword from both fields. Now there is no class field called face or numSides. Each die object I create will have its own copy of the fields, and when I run the program, each time I run it, I get different values for the different die objects, with occasional duplicates. So when do we use static? First, we already know about declaring main as static, which means we don't have to create an object before we run our program. And we can write a whole program that way, with static methods and even static class-level variables. There are classes in the Java standard library that include static methods and fields, such as the math class. In fact, we never make a math object. We simply have access to math methods like abs and square root, and fields like pi, e, and tau by prepending them with the name of the class, math. Static methods are often utility methods, like the ones in the math class. The string.format method is another example of a static utility method. Methods like integer.parseInt and double.parseDouble are also static methods. We don't send these messages to instances of string, integer, or double. We write the class name, dot, method name, and pass in arguments. You can also have a static field in a class that is meant to be shared among all objects. A counter that keeps track of the number of instantiated objects is a common use. For example, I could add a static counter to my die class and initialize it to 0. I'll create the counter and an accessor method for it, getCount. In the constructor, I'll add 1 to the counter field with die.count plus equals 1. The constructor is invoked when we create a new die. So this field will get incremented every time we create a new die, and will always hold the number of die objects that have been created so far in the program. In the testing program, I'll print the value before I create any of the die objects, and after each one is created. And when we run it, you can see that value increasing by 1 each time we create an object. So your rule of thumb is this: when writing classes meant to represent individual objects, fields are usually instance fields and not static fields. I hope this video gave you a little insight into static fields and methods and the sort of error that you might see if you unintentionally make an instance field static. If you have any questions or comments, please drop them below. And as always, have fun and keep coding.